Hello friends at IAL. I am Gothamie Weerakoon. Greetings to you all from London. We will talk about longitudinal gradient in species richness in the tropics using family Graphidaceae as a case study. Graphidaceae is the largest family of tropical lichen-forming fungi, one of the best studied lichen families. Existing molecular studies looked at the phylogenetic placement of taxa from all over the world. We wanted to test two hypotheses using family Graphidaceae. Our hypotheses are there two longitudinal richness gradients where species richness overall and mean species richness per genus appears to be higher in Neotropics? Second one, genus or biotype richness appears to be higher in the Eastern Paleotropics? I now want to draw your attention to this plant diversity map. You can see this well-known latitudinal gradient of plant diversity in the world. Is there a longitudinal gradient, especially between Neotropics and Eastern Paleotropic? I wish to raise this question for the audience. If we carefully look at this map, it is obvious that Africa has a lower plant diversity. Also, we can see from the map for plants, there does not seem to be a longitudinal gradient since Neotropics and Eastern Paleotropics both have red areas. Also, I like to draw your attention to some weird or unique form of plants. Please see the placement of Rafflesia biobag dragon blood plant on the map. This shows that there are some really weird things concentrated in the Paleotropics. However, there are also from weirdies in the Neotropics. Now, I like to recall your memory and show you this publication from 2014. 175 species Graphidaceae publication of Looking et al. Predicted that number of missing Graphidaceae species yet to be discovered is 1,800, and most of them will be recorded from Neotropics. Weerakoon et al. 2019 compared species richness in Paleotropics and Neotropics. Data from 4 countries that were well sampled was used for the comparison. These 2 papers were the source of the 2 hypotheses what we decided to test. And we are testing the hypothesis considering data collected since 2014. On slides 7 and 8, I'm going to show you distribution of weird or unique Graphidaceae in the world. You can see the first 3 genera, Ostotrema, Compositotrema, and diaphragmographies, they are more confined to eastern Paleotropics, whereas Enicotrema and Gyrotrema are mainly found in Neotropics. And some of the other genera, they are pantropical. To test our hypothesis, we updated the Graphidaceae checklist for several well-sampled countries. Also, we updated the global grid map listing from 2014 to 2021. The data was used to conduct species richness and lineage analysis. We have preliminary results at the grid square scale. Work is still in progress on distribution modeling at finer scales. The total number of unique species grid observations increased from 5,569 to 7,461, and sampling effort has increased, especially in several neotropical grids, but also in some of the eastern Paleotropics. Overall richness is higher in the Neotropics on average, but comparable between Neotropics and Eastern Paleotropics in the best sample grids. So the difference in the mean is likely a sampling issue. Same for the low values for Africa. Genus numbers are highest in the Neotropics, followed by Eastern and African Paleotropics. This table clearly highlights how much less effort is put on sampling in African Paleotropics, and that has affected species and genus records. The total number of subtropical Graphidaceae has increased. In year 2014, it was 2005. Currently, it is 2,380, which means in 7 years, we got about 25% of the predicted missing species. Many of them got recorded from Neotropics. Here is the DCA of 2014 and 2021. Note, axis 1 is flaved. Eastern Paleotropics to the right in the 2014 DCA, to the left in 2021 DCA. Here we show Neotropic grids in orange color, African Paleotropics in purple color, and Eastern Paleotropics green color. The African semi-arid grids have even more truly different species composition from the others. With the added new data, the rest of the African Paleotropic grids now appear to overlap more with the Neotropics than with the Eastern Paleotropic, rather than appearing intermediate between the two as before. This is 2014, this is 2021. Not only do the Neotropics and Eastern Paleotropics have more in common than appeared in 2014, the non-arid African Paleotropics appears notably more distinct from both the Neotropics and Eastern Paleotropics than before. Anchor in the right end of axis 1. On the other hand, the semi-arid African paleogrids, here they are, remain truly different based on a clearly different set of species on an independent axis. That's very likely a completely different course from pattern on axis 1. Dendrogram confirms semi-arid African paleogrids are different from all the others. Here they are in purple color, the most distinct of 3 major groups. The rest of the dendrograms gives an interestingly slightly different story from the neoordination. The central large group of grids gives one large group distinct from the other two but divided into 2 equally distinct groups. One all neotropic grids, the other almost all Eastern Paleotropic grid. The third large group has about equal number of grids from all 3 regions. Here it is. The large amount of chaining in this group suggests it is an artificial grouping of grids that are really different from those in the other 2 large groups, not really having all that much in common within that group. The base linkages, those furthest to the left in that group, here it is, are much further to the right, less similar within than those base linkages in the other 2 groups that do have some internal similarities. Our analysis show that African semi-arid are distinct from all the other grids, distinct species and pattern, probably independent of sampling effort distortion. Similarities across as well as distinctions between most Neotropics and Eastern Paleotropic grids. Increased sampling effort has allowed some similarities to emerge, though distinction between the 2 regions still strong. Several grids from all 3 regions have really distinct species assemblages, apparent from dendrogram even with quite different sampling efforts. There is no evidence for a longitudinal richness gradient other than caused by sampling effort, although Africa is difficult to judge. Also, unique genera are more numerous in the Neotropics. So, both our hypotheses are not supported by our study. All of us, the co-authors on this paper, wish to thank our institutions and all the other funding agencies that supported our joint effort for this project. Thank you very much to all of you and wish you good luck with your presentations and enjoy IAL 2020.